everybody. Welcome to the second Automation Engineers Gathering of 2019. It's the 14th of February, so happy Valentine's Day. Please mute if you're not intending on speaking. Thanks for being on time. And please note this gathering is being recorded and the video will be made available to watch later. I'm Dave Hunt, Engineering Manager for the Firefox Performance Testing team. And I started these gatherings as a way to keep up with the latest projects and practices. The format's a monthly gathering with a guest to talk about a project they're working on. It's the kind of thing that I like to attend, so I started it for selfish reasons. Please join Automationeers on IRC or Slack, as these can be used for sharing resources and can be used for discussions and questions. I try to schedule these meetings every month. The time and dates vary depending on the guest's availability. So look out for an invitation for next month's gathering. It should be out soon. And I've got a couple of exciting ones coming up. If you're interested in being a guest in a future gathering or have feedback or suggestions for guests, please send me an email. As usual, we may not use up the full hour, and there will be time for questions. If you've just joined us, I'd like to remind you to please mute and note once more that this event is being recorded. So finally, all I need to do is introduce our guest. Andrew Halberstadt, AHAL on IRC, is joining us from his home in Kitchener, near Toronto. He first joined Mozilla in 2010 as an intern, working in the Automation of Tools team, or A team. His first project was building a test framework for Firebug, and he became a full-time employee in 2012. I'm personally convinced he knows everything that's worth knowing about the Firefox build system, and he's my go-to for reviewing Python patches in Mozilla Central. Today, he's going to be showing us his knowledge of task configuration with taskgraph. So please join me in welcoming Andrew as our guest.
Thanks, Dave. So, yeah, my talk is called Task Configuration at Scale. So I think we should start off with a few definitions. So what is scale? Everybody probably thinks of CI scale differently, so here's some concrete answers. We have about 15,000 unique tasks in our task graph, 410 pushes per weekday. We average roughly 560 tasks per push, so it comes out to 230,000 tasks per day or so. This is just for the weekday. There's a lull on the weekend, obviously. Some larger organizations might kind of scoff at these numbers being referred to as scale, but I think for an org Mozilla size, they're fairly impressive numbers. At the very least, most of the off-the-shelf CI systems like Travis and Circle CI and the like don't really fit our needs properly, so that's why we pay a whole team of people to develop our in-house CI system called Task Cluster. I said we have 15,000 unique tasks. What does unique mean? Ignoring runtime information like timestamps, repo change sets, etc., every little difference counts. So if you have Linux 64 opt multi-test chunks 1 to 5, that's 5 unique tasks, even though there's only one single difference between them, and that's the chunk number. So if you think of it that way, there's a lot of similarities in those 15,000 tasks I mentioned before. You know, multi-test running on Windows 64-bit is very similar to multi-test running on Windows 32-bit. So the number's a little bit less impressive if you think of it that way, and it kind of raises the question, like, how do we deal with all of this duplication and all of these similarities? So the first half of the talk is going to be kind of going over the problem, defining some concepts, some kind of high-level ideas, and then the second half is actually going to be diving into taskgraph, which is our module for handling all of our configuration. Wet versus dry, this is something you may have heard of before. Wet stands for write everything twice, or we enjoy typing. Dry is a lot more commonly known as a don't repeat yourself, popular programming principle. And it's often used in the context of coding, but you can use it in configuration as well. Another way of putting it is duplication versus consolidation. I'm going to look at both extremes of the scale just to give a little idea of how this looks with config files. So in a write everything twice extreme, every single task is copy and pasted. So you have 15,000 task objects in files somewhere. Anytime you want to add a new task, you have to find some other similar task, copy and paste it, make the changes you need. The pros are that it's really easy to understand. There's literally no logic happening. The config files are in their final form already, so you can handle new requirements really well. But obviously, this is really difficult to maintain. If you want to make sweeping changes across your tasks, then you're going to be in for a bad time. You'll probably end up writing tools to do it, and then as soon as you write tools, then you have all the complexities of code anyway, and you can introduce bugs and whatnot. The other extreme, don't repeat yourself. Here, everything is almost everything is in logic. There's hardly any config files. You have for loops, you have if statements. There's really no pros, to be honest. Like I put some bullets there, but those aren't even really benefits. Really, both extremes are silly. We want our configuration system to have some kind of balanced approach. We want to be able to duplicate our configs in some instances, and we want to be able to refactor them into reshareable modules in others. Before I kind of expand on that idea, I'm going to show you an example. These are our BuildBot configs. BuildBot is the CI system we used prior to Task Cluster. I'm going to show you these BuildBot configs for a few reasons. First, it's an example of what not to do. Second, it gives a little bit of context of where we're coming from, like what our solution was before we were using taskgraph. And finally, actually, this file does have a couple nice examples of both wet and dry configuration in it at the same time. So it's really, how it works is really easy. We have this config.py file at the top. This contains all of our test configuration. There's a similar file for build configuration. But all that happens is you import it. We start building these global dictionaries here. And then at the end, whatever module imports it can just read the end state of the dictionary to get the configuration. So this here is our platform definitions. If I scroll down a bit, you can see there's already a fair bit of duplication. Like here's Win32, here's Win32 Dev Edition. If you look closely, they're almost identical except for a couple name changes and stuff like that. So this is an example of wet configuration. We copy and paste this chunk of configs anytime we want to add a new platform, and we make some modifications. Scrolling down, here's some suites, more wet configuration. I'm not going to go into it. I spent way too long modifying this file back in the day, and I've tried to forget. So I think it's around the 2,600 line mark, yeah. So there's a lot of duplication here. It's a lot of wet configuration. And then all of a sudden we start running into for loops. For loops after for loops after for loops after for loops, and it just goes on for quite a while. And this is an example of dry configuration. So what these loops are doing, they iterate over one of the dictionaries we defined earlier. And then for each item, we make some kind of modification, some kind of change. So we aren't doing any duplication. We're consolidating it into this in-code logic here. The benefit of wet configuration is that I can modify one specific thing. So for example, if I only want to modify this Mac OS X 64 key here, I can do so without fear of breaking any of the other platforms, or same with suites, for example. So it's very handy if I just need to change one instance of the config. The benefit of the dry configuration, on the other hand, is I can modify everything at once without adding all this duplication that just clutters things up and makes things harder to find. This file, again, is what not to do. There's no rhyme or reason for anything. I think what happened was we copy and pasted configuration for a long time, and then eventually it started getting too tedious to make changes, so someone decided, oh, let's just put a for loop at the bottom, and then someone else saw that and decided to copy them, and it was a real headache to deal with this. So what did we learn from BuildBot? I think the key takeaway for me is that not all configuration is equal. Sometimes you can have configuration that changes frequently. I'm going to call that dynamic configs. Sometimes you have configuration that hardly ever changes, and I'm going to call that static configuration. These aren't industry standard terms or anything, so don't go Googling it. But dynamic configuration in general, I think, should be wet. That's because you need to change it pretty often. The requirements around them change pretty often. You don't want to be modifying for loops and if statements and adding exception clauses and all that kind of thing on a regular basis. It's a very nice property to be able to modify something in a config file and look at the diff, and you see what changes, and it's easy to understand. And if you're doing that very often, you want it to be duplicated in your config files. Static, on the other hand, it's better to be dry. You don't want to repeat yourself. And that's just because they hardly ever change. You don't want config files that are 200 lines long for each task. I think some tasks approach that. So you just want to keep things simple, nice and easy to understand. You want to pay the cost of some in-code logic up front for the benefit of easier maintenance down the road. So problem solved. No, not quite. So that's just kind of a third of the story, or even less. So imagine this concept called configuration groups. So let's say we take the set of all tasks. That's a group of tasks, and let's try to break that down a bit. And for this example, I'm going to break them into release and product tasks. So release is kind of all the rel-ng type things, updates, build, signing, that kind of thing. Product is anything you might see on your try push, builds, test task. And then let's go a layer down. I'm going to take the group of all product tasks and try to break it down into build, test, and lint tasks. And you can keep going down the layers here, all the way down to, I don't know, say chunk is probably the lowest level group you can possibly think of. And those are all the tasks that only differ by their chunk number. And why you might want to do this thought exercise is because at every single stage, at every one of these groups, you can possibly conceive of configuration that would apply to all the tasks in that group. And it starts to get really complicated because some configuration might be static at a low level but dynamic at a high level. For example, in this group of tasks that are all the same except for their chunks, let's use artifacts as a configuration example here. Artifacts are just the output of a task. So for test tasks, artifacts are typically just log files. You can't imagine, Moki test chunk 1 outputting one type of artifact and Moki test chunk 2 outputting a completely different type of artifact. That just doesn't really make sense. You want, at this level, your artifact configuration is static. It doesn't change relative to the tasks in this group. But as you go higher up, suite artifacts are probably still static at this point. Get up to test, maybe it's a little gray area, but let's go up to the product level here. It's obviously the case that build tasks produce different artifacts than test tasks. There's almost no similarities between these two different kinds. So at least at the product level, you can say that artifact configuration is dynamic. And this is very confusing, and my only point of really bringing this up is that it's a really hard problem to figure out where you change configuration and how you apply it to your config files and your tasks. So I'm going to come back to this slide later, so hopefully it'll make a little bit more sense a few slides down the road. So the challenge for us is, how do we design a configuration system that's easy to understand and maintain, easy to modify both for individual tasks or any specific group of tasks, whether that's at a low or high level. We need to be able to handle changing requirements and uncertainty. We want to be able to extend tasks without breaking the world, and we don't want to have more duplication than is really necessary. It can be good in some cases, but when we don't need it, we want to get rid of it. So task graph is kind of our solution to this problem. It's not to be confused with task cluster. Task cluster is often kind of bandied about as the all-encompassing word for a CI system. But when people who work on this stuff say task cluster, we generally mean the service that lives in the cloud. It's not in tree, it's developed in GitHub, and you submit tasks to it over a REST API. And then task graph is the core module that generates our task configuration in tree. It's technically completely unrelated to task cluster. Like, we could write any number of task graph like modules, but this is what we've come up with for Mozilla Central's use case. Confusingly, it does live under the task cluster directory in the tree. So there's two directories that are important for the purposes of this talk, at least. There's task cluster task graph, which is the core module that handles graph generation. And then there's task cluster CI, which has all of the YAML files that contain our initial configuration. You can find some Firefox source docs at this link. It'll come back up again at the end of the talk. And taskgraph was originally designed by Dustin Mitchell, who's got a lot of CI system experience under his belt. He was one of the primary authors of BuildBot, and to this day is still helping us build task cluster. But these days, he's a little less involved with the task graph module, and there's kind of a shared ownership between the build team, my team, CI automation, Relinge, task cluster, and a bunch more that I'm missing. So I'm going to mostly focus on how tasks are generated. But before I do that, I just want to give a very quick and high-level overview of the entire generation process, and I'm just going to steal from the source tree docs here. So the first step is we load and generate all tasks. So that means reading the YAML files under task cluster CI. We'll create dependency links between them, and that creates the full task graph. So in the full task graph, nodes are the tasks themselves, and dependencies between tasks are the edges. And it is a DAG, a directed acyclic graph. After you have the full task graph, we filter that down into what we call the target task graph. So when you push to a branch let's say you push to Autoland or Mozilla Inbound, every branch has different rules that determine which tasks are valid on that branch. For example, the tasks that run on Mozilla Release are not the same as the tasks that run on Mozilla Central. Try is the black sheep here. It has very different rules from everything else because we take into account try syntax and try taskconfig.json when you push to try. But when you have the target task graph, that's basically every task that is valid on the branch that you're pushing to. After that, we apply some optimizations. Essentially, we don't have the resources to run every task on every push, so we optimize them pretty heavily. If you've ever heard of SETA, that's the main way. That's our main optimization method. We are looking into integrating code coverage this year as well. But if you remember from my first slide, I said there was 15,000 tasks and only 500 or so ran per push. It's the task graph, or sorry, the target filtering and the optimizations are the two steps that really reduce the number of tasks that run per push. There's a stage called morphing the graph, but I'm not going to talk about that because it's kind of irrelevant. So the rest of this talk is all going to be this part right here, bullet number 1. As a developer or as someone modifying the task graph, you don't really care too much about steps 2 to 7. You're probably only going to care about the actual generation of the tasks themselves. If you get past step 1, you can be pretty sure that the rest of steps 2 to 7 are going to pass for you. They might not do exactly what you want, but so if you want to kind of get a feel for how the generation works, you can actually run everything locally. Mock taskgraph -- help will give you all the different steps that I just talked about. For example, mock taskgraph full will generate the full task graph and then exit. By default, it only shows labels, but if you pass in -j, you'll get the full JSON output. I think if you run mock taskgraph full -j, the prettified JSON is over 2 million lines, so it's a bit of a handful to search through. It's not the greatest way to debug. So this is step one of phase one, I guess, from the documentation I was showing you. So the first thing we do is we get a big list of every task, and we do that by reading all the YAML files under task cluster CI. Couple concepts I'll mention: kinds, jobs from, jobs defaults, and transforms. So let's take a look at what they look like. This is Mozilla Central Task Cluster CI. That's the directory that has all the YAML configuration in it. And every directory you see here corresponds to a kind. A kind is just a term in taskgraph that we use to denote some kind of logical grouping of tasks. So if you think back of that configuration group slide I had, kinds are one way that we signal that the tasks, all these tasks with the same kind, are in some way or shape or form related to one another. So for example, here's the build kind, and all of our build tasks are defined in these files here somewhere. These are Linux builds. You see a lot of release engineering kinds. I don't really know much about them, but I kind of suspect we could merge them together. But anyway, these are the test tasks here in the test kind. So that's all of our Moki tests, web platform tests, Raptor, ref test, all that kind of thing. And I'm going to show you source test as an example, just because it's a little bit simpler than the test kind. So source test has everything that runs from a source checkout, like Python tests. These are some lint tasks, JS shell, benchmarks. So anything that you would, the commonality of all these tasks is that we clone Mozilla Central and then we run some kind of mock command, and they all tend to be pretty simple. We could probably find some better way to organize them, but for now it's nice and simple, so it's not really worth it. Every kind has a kind.yaml file, so this is kind of the main definition of a kind. The first thing you'll often see is transforms. That's really important, and I'm going to talk about it later, but I'm going to skip over them for now. And the next thing you'll see is this jobs from key. So this just corresponds to all the other YAML files in the same directory. And this tells the loader to look in these files for tasks and load tasks from there. So I'm going to look at python.yaml, which again is our Python test tasks. Here's a task that defines the unit test for the task graph module itself. So you can see run using Python test. This will basically just run mock Python test in the task itself, the same way you would locally if you were running these tests. So every task here there's a lot of duplication. So this is what I would call wet configuration. But then at the very top, we also have this job defaults key. And this will apply these values to any tasks defined below that weren't explicitly defined. So tasks can override these values, but if they don't have them, then these will fill in the defaults. So this is the first place that we kind of see the balance of wet and dry configuration come into play. Also, if you think about the configuration group slide, all the tasks defined in python.yaml have some kind of similarity with one another. In this case, they all get run with mock Python test. So job defaults is a good place to add configuration that we want to affect everything in that group. And you still have the ability to add configuration to individual tasks as well. So going back to kind.yaml, let's say we wanted to add some kind of configuration that affects every task in all of these files here. So in other words, you want to add configuration for all of the source test tasks. How would I do that? So this is where transforms come into play. So transforms, if you think back to the buildbot configs example, I was kind of saying how horrible all of those for loops at the end of the file were and how hard it was to understand everything. The bad news is that transforms are also just for loops with some syntactic sugar around them. You can think of a transform. A transform is just a function that takes a list of tasks as input. It'll typically iterate over that list of tasks and make some modification along the way. The key difference between transforms and the for loop approach of the buildbot configs is that they are organized and well defined, and we validate them at every step of the way. We actually have schemas to make sure that transforms output the job definition or the task definitions in the format that we expect. And I'm going to show you some examples, but it makes everything much nicer. So looking up, this is back at the source test kind.yaml. Looking up here in the transform section, we have, I'm going to ignore try job transforms just because it's not that interesting. But ignoring that, we have 3 different layers of transforms that we apply. First are the source test transforms, then the job transforms, then the task transforms. The first part of this key is just an import path, so we're going to do from taskgraph.transforms.sourceTest import, and then this is just the value that we're importing. It's just a list, a glorified list basically. So let's take a look. I'm going to go back to the task cluster directory, task graph, transforms, source test. So the first thing you'll see in a transform file is a schema typically. And schemas get added right near the top of the file. So what this does is it lets us know that all of the YAML files in the source test kind must conform to this schema. So we know for sure that they all have a platform configuration. They all have require, build, worker type, and worker, and they can optionally have a Python version. So this is very useful for debugging. Like we can make assumption, like we can assert, or we do assert that they have these keys. So it makes it a lot easier to know what the format is of the task that you're operating on. As you scroll down, you'll see we start seeing some transform functions. We have a little decorator that gets them registered. And the input is just the task cluster config and the list of jobs. And I said transforms were just for loops again. Well, here we are iterating over the job lists, and we make some modifications. There's if statements. We can have loops and loops. So this is just dry configuration, the same that you would have seen in the buildbot config.py. This expand platforms transform is pretty interesting because we're iterating over all the tasks, and then we have an inner for loop, which is deep copying the task and then yielding multiple copies of that task while changing the platform. So this specific transform, let's say the task is that I should run on Linux, OS X, and Windows. This transform is duplicating the task and taking that one task and turning it into 3 that are all identical except for the platform config. And we use this pattern all over the place. This transform is splitting tasks into Python 2 and Python 3. This transform is splitting tasks into SpiderMonkey and Google V8. These are the JS shell benchmark tasks, and so on. Now I'm going to go back to kind.yaml for a sec. After the source test tasks, we have job transforms. So let's take a look at job. Task graph, transforms, job init. Again, you'll see a schema up at the top. This one's a little bit more involved than the source test ones. But because this schema gets applied directly after the source test transforms finish, we have to make sure that the source test transforms output tasks that follow this schema. And again, if you scroll down, you'll see a whole bunch of transforms being added. This one, use fetches, is pretty complicated. So transforms can be as simple as a for loop that modifies some configuration, or it can get a little bit hairy. It's definitely not a perfect system, but it does pretty well. After run task, after job transforms, the task transforms get applied. So let's open those up. Once again, you'll see a schema at the top and transform functions down at the bottom. Now, the task transforms are pretty special because, as far as I know, every single task in the task graph uses them. So we use this set of transforms to kind of that final little push to get the tasks ready to submit to the task cluster service. So we add things like scopes and like API URLs and environment variables that task cluster expects and that kind of thing. Now, after all the transforms have been applied, we have something called, well, that's when we have the full task graph, which I talked about earlier. And then from there, the rest of the graph generation process takes over. So we'll filter out the target tasks, apply optimizations and morphs, and eventually submit the morph task graph to task cluster the service via a REST API. There's a couple of things I want to call out about this system in relation to the concepts I talked about earlier. First, we kind of have this split of dynamic and static configuration. Typically, we want the dynamic configs are all in the YAML files, things that change pretty often in relation to their groups that they're in. And we typically have static configuration defined in transforms. There's exceptions. We don't follow the rule perfectly, but on a very broad scope, I think that's true. But more interestingly, if you go back to the configuration group slide I had, you can easily find a place to modify any type of group you can think of, more or less. So if you want to make a change to an individual task, you can do that by adding a key to the YAML file in Task Cluster CI. If you want to make a change to, let's say all lint tasks, for example, you can do that by adding a key to the job defaults in the specific jobs from key that those tasks are defined in. If you want to make a change to all tasks in a kind, you can do that in the lowest level transform. Typically, all kinds have an associated transform file, or maybe at least in the kinds that I work with day to day. I'm not sure about the release engineering kinds, but you can always create a new transform file if you have to. Then you can have as many arbitrary stages of intermediate transforms that you want. You might want to try to keep those somewhat limited, but it can be useful if you're working in a kind of a sub part of the task graph that's really complicated. The test kind is one example of this. And then at the very highest level, you have the task.py transforms, and a modification there affects every single task in the task graph. So it just kind of shows you how, no matter where you want to make configuration, you have options, and you can usually decide to make it wet by putting it in the config files or dry by putting it in the transforms. So it's very flexible. So I guess that's the question. Did we succeed? Task graph, well, succeed at our original goal of the challenge from my slide a while back. So task graph isn't perfect. It's difficult to understand when you first look at it. Kind of, I imagine many of you are scratching your head at this presentation right now. It's not always obvious where you would set configuration. It takes a lot of intuition. And different people have different ideas of how to organize things, so you get a lot of inconsistencies between different task kinds, especially if those kinds are owned by different teams. And it's extremely flexible with very little gatekeeping, which is a plus, but also it opens the door for all kinds of weird tasks and hackiness that creeps in. Over time, the complexity just keeps getting bigger and bigger. But all that being said, I do think taskgraph is a big success. I think when Dustin first asked me to look over his proposal, I was kind of thinking a little, what is this and why? But the more I work in taskgraph and the more I come to appreciate all the flexibility and things it lets you handle quickly, I think it is a pretty brilliant solution to the problem. It allows us to move fast. We can handle any requirements changes we can throw at it. There's plenty of places you can balance wet and dry configuration, even if the implementation isn't always perfect. And you can modify groups of tasks at pretty much any level you want. You know, where those levels should be can often be a contentious matter, but you know, the ability to do so is there. And I think the biggest thing that taskgraph has going for it is that it's self-serve and in-tree. And this is extremely powerful, as developers can and have created many of their own tasks just without even any prompting from us. We are no longer the gatekeepers for creating new tasks. So that's all I had. I have a couple of links up here. The first one's to these slides. The middle one is to the Firefox source docs taskgraph documentation, which is again confusingly called task cluster. The third link is the task cluster service docs. I haven't touched on anything in those docs, so I just put it there in case you're interested in learning more about how the service works, but it's pretty irrelevant to taskgraph itself. With that, I'm going to open the floor to some questions.
Thanks, Andrew. That was awesome and really detailed. So I think I have a question. So if a change is made to a transform, or I suppose not just a transform, but other parts of the configuration, and it's done in error, it could have quite a huge impact on the number of tasks generated. Either way, like it could explode, or it could drastically reduce the number of tasks. I was just wondering if there is any, other than the review process, is there anything that protects against errors like that?
So hopefully the schema will catch that. I think you can't have, there's a lot of keys that can't be duplicated. So if you detect a duplicate task, it'll error out. If you have a for loop and you're yielding tasks out of that for loop and you somehow iterate too many times, there's only certain values that you can add in. If you accidentally iterate too many times and all the values turn out to be valid, then it won't really catch that. I mean, the sheriff will probably notice when they see 1,000 job symbols on treeherder and back you out. But yeah, the schemas are pretty good at catching errors like that. When I didn't really mention this, but the main benefit of the schemas, I think, is that they stop you from making typos. In the BuildBot config land, you would often make like a silly little typo and you wouldn't notice, and then you'd push it, and then it would wreak havoc when you actually went live. Here, you can't even generate the task graph without getting an error if you type in a key that isn't defined in the schema. So I think the situation you mentioned is possible. I don't think it's been a big problem, and for the most part, the schemas have been pretty good at catching that type of error.
And is there a way to, it's been a while since I worked on anything related to the task graph, but is it possible to test things, test the impact of changes locally without having to push to try?
Yep, yeah, so I also probably should have expanded on this a bit, but when you run mock task graph full, that is running the decision task. So that when you see the decision task in treeherder, all it's doing is running mock task graph decision, and you can do that locally and it should be identical. So if you want to make sure everything works, if it works locally, it'll work in treeherder probably. I guess there's probably some edge cases where that's not true. Also, actually, if you push to try with mock try fuzzy or mock try chooser or one of the newer try selectors, it's also generating the task graph under the hood. You don't see it, but that's what's happening. And it's using the output of the task graph to make decisions on what you can select in your little try selection interface. So I know some people actually just run mock try fuzzy to validate their task graph changes.
Does anybody else have any questions for Andrew?
I would have two comments. So first, thanks a lot for all the information.
Yep.
And I would like to add to that, especially on Linux, what I like is, given that we use Docker for the system configuration, that this is even all in Mozilla Central and Free. So if you have problems and you want to investigate some kind of regression, and you go back to some older commit on Mozilla Central and push up a try build, it will automatically even go back to this specific Docker image and rebuild it, which is even amazing. But that's only on Linux. It doesn't work on Windows and for Mac, because on Mac we use real hardware, and for Windows we use AMIs, which has configuration, I think, somewhere at Amazon, so we don't have source information in Stream. But when you do regression tests, it's really helpful to do it on Linux, even that you can use the one-click clone to log in via SSH and via VNC, which while the tasks are running. The second thing I want to ask is, you talked about the source tests. I can remember that there was an initiative to convert more tests away from harness to source tests. Has this been installed, or is this something which we still want to continue in the near future?
I think yes to both those things. I think it has been installed, and I do hope that we can continue that work in the near future. I don't think we'll be moving them to the source test kind specifically, but I think the larger effort we want to do is right now, when the test task will create, the build task will create a test.zip artifact, and then the test task will download that, and it contains all the test files, and it kind of adds a lot of complexity. So we want to move to a world where the test tasks clone Gecko instead, and then we just run out of the source dir the same way that you would if you're running locally with mock. It's kind of all kinds of benefits to that, but yeah, I'd say it's pretty stalled out, and I'm hoping we can get back to it at some point, but I don't think anyone's working on it.
Okay. It would make it way more easier to investigate problems on one-click loaners, for example. Using Moz harness to set up everything, it's a real pain. So I'm looking forward to having this.
Yes.
Okay, thanks.
Me too.
What's the best resource for somebody who wants to get started on creating creating a new task or modifying an existing one? You've got the Firefox source docs, but beyond that, is there an IRC channel, Slack channel? What's the best place to?
Yeah, you can join. I guess hash or #CI, I guess, would be a good place. Task cluster might be another good place. These docs here are kind of the only resource for the task graph module. I think we need to spend some time making them a little bit better. The problem with task graph is that it's designed to be so flexible that one kind might be wildly different from another kind. So if you're trying to add a new test task, it's going to be completely different than if you're trying to add a new build task, and that's going to be completely different if you're trying to add a new source test task even. So it is, I did mention that it's a little hard to understand task graph, and part of that difficulty comes with just how everything is so different from one another. So with the flexibility, yeah, there are some downsides that come with that as well. I would say read through these docs. Feel free to ping people on CI or Task Cluster. Feel free to ping me if you need help. I'm happy to help. And maybe eventually we can put a little section in here that can help out new contributors a little better.
So I had a question about chunking. It's a little tangential. The way I understand the chunking is it's really there to distribute the load.
Yep.
Do you see that there being, because it's great in achieving that, but I think a lot of people have maybe got used to it, but it's pretty horrible for for reporting purposes and trying to track where a test is.
Yeah.
Do you see there being a future where the chunks are stitched back together for reporting?
Yeah, I've actually spent a lot of time thinking about this, and we've come up with various project proposals to tackle this problem over the years, and they always end up getting deprioritized or stalled out or something. It's a pretty hard problem. I think I think it's almost more of a UI problem. If we always, at some level, we're going to need multiple tasks running different chunks under the hood. And I think the unfortunate thing is that right now we surface all those chunks in treeherder. So I think we need to solve this in treeherder such that it only displays one job symbol, and somehow we stitch the logs together. There's a lot of kind of moving parts and difficulties in doing that. So it is something we have thought about a lot, and I think we are moving slowly towards a world where that reality is more possible.
Cool. I think that would make a lot of people's first experience of treeherder a lot better.
Yeah.
So I think that's all of my questions. Does anybody else have any questions for Andrew? I'm going to take that as a no. All right. Thank you, Andrew. That was awesome.
No
I will I'll send out an invitation soon for our next gathering. But otherwise, yeah, thanks everybody. Take care and see you all next time.
Thanks for organizing this, Dave.
Sure, no problem.
Bye.